Okay, so we've practiced the chain rule. So the next bit is doing the reverse chain rule in order to do some integration, because integration is the opposite of differentiation. So all we need to do is find something that differentiates to give us these things, and we'll be able to integrate them. So 1 over x, what differentiates to give us 1 over x? Well, if you think back, if I differentiate ln x, we get 1 over x. So therefore, if I integrate 1 over x, we get ln x plus c. Now, something you'll see in a bit is we need the modulus magnitude symbol around x, because otherwise I wouldn't be able to have negative x's in there. But we know if you draw the graph 1 over x, you can't have negative x's. Okay, cos x, what differentiates to give us cos x? Hopefully you're thinking of sin x. So therefore, if I integrate cos x, I get sin x plus c. What differentiate give us sin x? Well, if I differentiate cos x, I get minus sin x. So therefore, if I take the minus to the side and I integrate sine, I should get minus cos x plus c. Now, a good way of remembering that is sine differentiates to cos differentiates to minus sine minus sine differentiates to minus cos differentiates to positive sine, and it keeps repeating itself like that. So it's a periodic sequence up, order 4. And if I go down, that means I'm differentiating, and up means I'm integrating. Sine 2x, well, let's think about it. We know it's got something to do with cos. So if I differentiate cos 2x, I should get, well, 2 go to the front, so I get minus 2 sine 2x. So I don't want the minus 2, so I have to divide by minus 2 there. So it'll be cos 2x divided by minus 2, which is the same as times by minus a half, plus c. E to the 4x. Okay, so let's try differentiating e to the 4x, and that gives me 4e to the 4x. So to get e to the 4x by itself, I need to divide by 4, so it'll be 1 over 4 e to the 4x plus c. This here, okay, this looks like it come from a bracket with power 6. So let's have a look what I get when we differentiate 4x plus 1 to power 6. Well, when I differentiate that, I'll get 4 from the bracket times 6 from the power, 4x plus 1, take away 1 to the power, so 5. So that gives us 24, 4x plus 1 to the 5. And that's what we wanted. So it's just 4x plus 1 to the power 6 plus c. It's just that bit. Next one, 4x plus 1 to the power 5. So again, it's the same as this one. It looks like it should come from this, but I've got a 24 at the front, whereas here I don't want a 24 at the front. So it's going to be the same thing, but just divided by 24. So 1 over 24, 4x plus 1, power 6 plus c. Next one, we've got 4x squared plus 1 to the power 5. So again, let's try power 6. So 4x squared plus 1 to the power 6. So differentiate the bracket, so 8x times by differentiate power, so 6, 4x squared plus 1 to the power 5. So that gives us 48x, 4x squared plus 1 to the power 5. I don't want 48, I want 24, so I need to divide by 2. So it's a half of that bracket there, so 4x squared plus 1 to the power 6 c. This thing here, I'm going to rewrite that as 2x minus 1 to the power minus a half. Well, what differentiates to give us notes like that? It'll be power of a half. So if I try differentiating 2x minus 1 to the power of a half, I get differentiate brackets of 2 times the power of a half, take away 1 to the power. So the 2 and a half cancel out. So 2x minus 1 to the minus half. That's what we wanted. So it's just 2x to the minus 1 divided by half plus 1. Next one, again, I'm going to rewrite this as 2x minus 1 to the minus 2. So what differentiates to give us that? And minus 1 would be the power. So let's try 2x minus 1 to the minus 1. So if I differentiate that, I get 2 from the bracket times minus 1 from the power. Take away 1 to the power to get minus 2. So that gives me minus 2. 2x minus 1 to minus 2. But I don't want that minus 2 there. So I need to divide by minus 2. So that's times by minus half. So 2x minus 1 minus 1 plus 2. Next one, I'm going to write that as 2x minus 1 to the minus 1. Well, what differentiates to give me power minus 1? It's an ln. So let's try differentiating ln 2x minus 1. So that gives me differential brackets of 2 times 1 over 2x minus 1. So 2 over 2x minus 1. I don't want a 2 on the top, sorry. I want a 1, so I need to divide by a half. So it's ln, and again, I need these magnitude brackets, 2x minus 1 plus the c at the end. 1 over 2x, well, that's just a half x to the minus 1. Well, that one to integrate, well, the half stays as it is. And then x minus 1 just goes to ln x plus c. I should roll that next to it. Half ln x plus c. Next one. Oh, fractions, these look a bit tricky. However, if you remember that rule when I differentiate ln's, that if the top is the derivative of the bottom, it's going to be an ln. And also, the only thing that's given us fractions so far is ln's. So, if we try differentiating ln 2x squared minus 1, we get differential of the bracket, so 4x times 1 over 2x squared minus 1. So 4x over 2x squared minus 1, which is what we wanted. So if I integrate, we'll just get the ln 2x squared minus 1 plus a c. And the last one is the same as this one, look, but we've got rid of the 4 and changed it into a 3. So it's the same answer as before. Just this time, I need to divide it by 4 to get rid of that 4, and then times by 3 to get that 3 in there. So it's the same as times by 3/4. So if we look back on page 6, we've got this table here. So it's kind of the opposite. So if I'm integrating, sine kx, well, sine, what difference between sine? Well, it's minus cos. And to get the k there, well, if I differentiate cos kx, I would get k at the front, so I need 1 over k. Again, what differentiates to give me cos? That's sine. And I need 1 over k at the front, so that I don't get any k's there. Tan is a bit trickier to integrate. We'll do that at a different point. E to the kx, well, again, e to kx differentiates to give e to kx, but I would have a k at the front, so I need 1 over k to cancel that out. And then this last one, well, it's just 1 over k, x to the minus 1, which just gives me ln x, and then I need a plus c in all of them, so just going to put plus c in the top. Yeah, we'll do integration again at some point, because it is tricky. Okay, and on page 9, we've got just 3 more. So part A is asking us to differentiate ln 5x squared take away 3. So if we differentiate it, I get differentiate the bracket gives us 10x times 1 over, ln differentiates to 1 over the bracket, so 5x squared take away 3. Simplify to 10x over 5x squared minus 3. And B, well, it wants us to integrate that. Well, if I integrate 10x over 5x squared minus 3, I should get ln 5x squared minus 3, just from part A. Look, if I integrate that, I get back to where I started. But if I want 7 at the front, that means I need to divide this thing by 10 and then times it by 7. So if you look, the 10s will cancel out, so I'll just be left with 7x. So it's just 7 over 10 ln 5x squared minus 3 plus c. And again, I just need these magnitude brackets as well. Tan x, well, to integrate it, first of all, I want to write as sine x over cos x. Okay, and again, it looks a bit like a fraction, so it looks a bit like sine x cos x minus 1. So that suggests using logs. So if I try differentiating log of cos x, well, I would get cos differentiates to minus sine x times 1 over log would be 1 over cos x. So that gives me minus sine x over cos x. That gives us minus tan x. Okay, so if I integrate minus tan x, I get ln cos x. So to integrate just tan x, I need to take the minus over. So tan x integrates to minus ln cos x plus c. And minus, remember, I can take to a power. And 1 over, or minus 1 means 1 over. So 1 over cos x is sec x. And I need my magnitude brackets around that. Okay, and last one, find cos x squared x. So if you look in the differentiation section of the formula booklet, you'll see that if I differentiate cot x, we get minus cos x squared x. So if I integrate minus cos x squared x, I get cot x, but I don't want a minus there. So if I integrate just cos x squared x, the minus should go to the side. So I should get just minus cot. Let's see. It's all about looking at the right place.